Hello student, this is my lecture on real analysis for third time honors and GE student. I, Miss Ranjana Datta from the Department of Mathematics, the Graduate School College for Women. Today we are going to study the Lagrange's mean value theorem. If a function f is number 1 continuous in the closed interval AB and number 2 differentiable in the open interval AB, then there exists at least one point C in open interval AB such that fb minus fa divided by b minus a is equal to f dash c. Consider the function phi defined by phi x is equal to fx plus ax, where a is a constant to be determined such that phi a is equal to phi b. So phi a is equal to fa plus aa and phi b is equal to fa plus ab. And then since phi a is equal to phi b, then after calculating that we get a is equal to fb minus fc by b minus a. This is now it is given that fx is continuous in the closed interval ab, and also x is continuous in the closed interval ab, and also x is continuous in the closed interval ab. Hence the function phi x is equal to fx plus ax is continuous in the closed interval ab. Again, it is given that fx is differentiable in the open interval and x is differentiable in the interval. Therefore, phi x is also differentiable in open interval ab. Hence, all the conditions of Rolle's theorem are satisfied for the function phi x. Therefore, there exists at least one point in the open interval AB such that phi dash c is equal to 0. So, phi dash x is equal to f dash x plus a, and phi dash c is equal to f dash c plus a. Putting x equal to c, we get phi dash c is equal to 0, f dash c is equal to minus a. Now from 3 and 4 we get fb minus fa by b minus a is equal to f dash c, which is the theorem. Now, the geometrical interpretation of Lagrange's mean value theorem. Let the figure ACB be the graph of the continuous function fx in A and B, and let the chord AB making an angle alpha with the x-axis such that tan alpha equal to fb minus fa divided by b minus a is equal to f dash c by mean value theorem, where c lies between a and b. This geometrically means that there is some point in C in AB such that the tangent to the curve at this point x equal to c is parallel to the chord AB. So now we take some example. Find C of the mean value theorem, where f dash c is equal to fb minus fa by b minus a if fx is equal to x into x minus 1 into x minus 2, for a is equal to 0, b is equal to 1 by 2. Here fx is given, so f dash x is calculated. Now f dash c is equal to this much, and f dash c when equated to f half, when taking a equal to 0, b equal to half, and after that we get this is equal to 3 by 4. So after calculation we get c is equal to 1 plus minus root 7 by root 12. Since C lies between A and B and C lies between 0 and half, therefore we must have C is equal to 1 minus root 7 by root 12. Now let's take another example. Prove that tan x is greater than x whenever x lies between 0 and pi by 2. Let C be any real number such that C lies between 0 and pi by 2. We take the function fx is equal to tan x minus x for x, all x lies between open interval 0 and C. Obviously, fx is continuous. You have to prove here that fx is continuous. Obviously, fx is continuous and differentiable in the open interval 0 and C. So, fx is equal to f dash x is equal to sec square x minus 1, that is tan square x, and it is greater than 0 whenever x lies between 0 and C. This implies that fx is strictly increasing whenever x lies between 0 and C. So fc is greater than f0. So, but f0 is equal to 0, therefore fc should be greater than 0. That is tan x minus x is greater than 0 when x equal to C. Since for any real number C, we can write it as C lies between 0 and pi by 2. Therefore, this follows that tan x is greater than x whenever x lies between 0 and pi by 2. Next, another example. Prove that 2 by pi is less than sin x by x is less than 1 whenever x lies between 0 and pi by 2. Let a function f be defined by fx is equal to sin x by x if x is not equal to 0 and is equal to 1 if x is equal to 0. Therefore, fx extends to 0 at x equal to 0, sin x by x is equal to 1 is equal to f0. Therefore, fx is continuous at x equal to 0. Also, fx is continuous in 0 to pi by 2 open interval. Hence, fx is continuous in 0 and pi by 2 close interval. Then when x is not equal to 0, we have f dash x is equal to x cos x minus sin x by x square. When x lies between 0 and pi by 2, then from the equation 1, we can say that tan x is greater than x and cos x is greater than 0. Therefore, f dash x is less than 0 whenever x lies between 0 and pi by 2. This means that fx is strictly decreasing in 0 to pi by 2 close interval, so that when x lies between 0 and pi by 2, we have f0 is greater than fx is greater than f pi by 2. That is, 1 is greater than sin x by x is greater than 2 by pi. Hence proved. So student, today this much only. Thank you.